Hello everyone, so in this video let us talk about one more problem from LEETCODE, which is a medium level problem. The problem name is maximum width of binary tree. The problem statement goes like this, that you're given a root of a binary tree and you have to return the maximum width of the given tree. Now the maximum width of a tree is the maximum width along, like maximum width among all the levels. Okay, among all the levels, whatever level has the maximum width, that is the whole thing. Now the width of one level is defined as the length between the end nodes. Okay, the leftmost and the right node, not null nodes. What is the distance between them of any level? That is the width of the particular level. So you have to maximize over all the widths of all the levels. So where all the null nodes between the end nodes, that would be also represented as a complete binary tree extending down, and it is guaranteed that the answer will be in the range between these signed. So let's take one example only. Let's say that for the first level it is only one node. Second level it has two nodes, but they both are there, so the distance between them is 1. Okay, for this, as you can see that this is at, like, this is at this particular point the end nodes at a particular level. So at this second level, 0th level, first level, second level, in the second level, you can see that there is one node at the very extreme left and one node at the very extreme left, right? So all these nodes, they at maximum there are 4 nodes possible. Okay, so if you find out the distance between this node and the last node, it is 4. Got it? So if I just draw it one more example, let's say if, let's say, it is a complete tree. If you want to find out distance between this node and this node, including these nodes, so it is 1, 2, 3, 4. Okay, even if I delete out this node, the distance remains same, because we are finding out a distance between the extreme nodes on a particular level. So this is the level, the extreme nodes, the extreme left and extreme right between a particular level. Okay, so that's the overall thing. But if, let's say, if I delete out this node, then the distance between them is this, which is 1, 2, and 3. Even if there is no node here, but we are assuming a distance there. But this is not assumed here because it is on the left hand side. But we will start from this node that is exists. Then this node does not exist. So we'll imagine a, let's say, imaginary node, and then there's this node. So all the nodes along this path. So 1, 2, 3. So this is the distances. Okay. But let's say there's also one example. Let's say there is no node on a particular level on the two extremes. So let's say that there is a tree like this. Okay, now on this particular level there is one node. On this there are like 2 nodes. This is 2. For this there is one left node, but there is no right node to block or to make a bound over this level. So this is not considered. So distance between them is 2 only. Okay, distance between them is 2 only. So that's the overall thing. Now you have to check it out how you can do. Now because you have to find out for a level, it's better to do just a level or a traversal over this whole tree. For a level, what you'll do is that for a level or traversal, what we'll do is that we will push all these nodes inside a queue. Now we have these values. So what we'll do is that we will give them indexes for a binary tree traversal. The indexes are that this is 1, then this is 2, then this is 3, then this is 4, then this is 5, then this is 6, then this is 7. Okay, this is how the the indexes of the binary tree is given to you. And whatever nodes you are on for a particular level. So let's say on this node, on this particular level, you have this node exists and this node exists, so you just get the distance between them. 7 minus 5, you can get a distance. So that's the overall thing that we will be using. If a node exists, whatever nodes exist in a particular level, we just find out the distance between them. Now how you can generate these indexes, it's also very pretty much simple. If you have done a traversal over binary tree, so if you go on the left hand side, you just do 2x, whatever value. So let's say if this value is x, whatever node value is x, if you have this particular index, the first root node always has a value of 1. When you go on the left hand side, you will just do 2x, whatever value it has, just multiply it with double, so it will become 2x. And if you go on the right hand side, it becomes 2x plus 1, so it has 2x, which is like 2 plus 1, which is 3. Now if you again go from 2x to this node, it is 2 into 2, which is 4. If you go from this node to this node, it is 2x, which is 4 plus 1, it is 5. If you go from 3 to double, it is like 6, and it is 7. That is how the indexes of a number like a binary tree works. And what you will do a binary, like a level or traversal over this whole tree, this level, over using a queue. We'll talk about that. And whenever you got a queue for a particular level, just take the first node and the last node that is present inside the queue for a particular level, and just find out a distance between these two nodes, and that's over. Okay. So now what you'll do is that you will do a level or traversal. So this is answer whatever is the maximum answer or maximum width you will get. If the root node doesn't exist, the answer is that you will just return 0 because There's no root node existing here. So we will push a particular root node inside a queue, which is showing out the tree node as well as the integer value. Integer value is showing out what is the index, because I want the index as well for a particular node, as well as the tree node value, like the node itself. So we'll push the particular root node, which is like, let's say they have started with 0th index. You can also start from 0th index as well. The tree node, you can give 0, but the condition remains that this will then become 2x plus 1, and this will become 2x plus 2. You can also start with x also, like 1 also, whatever you want. Then you can start from 0. Then you will do a while loop over each level. You will do iteration over this queue. So this queue has a particular level stored inside this queue. You will check that what is the start element of this queue, because this queue at any point is storing out the complete level. Okay, now you will take out the very start element from the queue and the last element. Both are marking out the very extremes of this particular level that you are on, and you will just subtract out the end minus start plus 1. You will get the complete distance, and you want to maximize it over all the levels. And then because when you have got the particular maximum width for a particular node, you will go to the particular level, you will go to the next level. For that, you will iterate over all the particular nodes inside a particular level and go to the next level by taking out all the nodes that are present inside the next level. So what you will go, that you will iterate over all the nodes inside that particular level, take out one node at a time, pop it out, and then you have two values. You have the particular node and its index. So for that particular node, you will go on the left hand side, on the right hand side. For the left hand side, you will just push that particular node as well as index. The index is 2 into index plus 1. The right hand side is 2 into index plus 2, because we are starting with 0. If you're starting with 1, it will be 2 into index plus 2 into index and 2 into index plus 1, whatever you want. And then if you're going to left hand side, you have to push that inside the queue. Okay, and that's a simple level of traversal. If you have not seen level of traversal on a binary tree, you can first check out that video. It will become more sense to you after seeing that. But just a level of traversal, we will do a while loop over the queue. And this queue at any state, when you are on this point, storing out all the nodes inside a particular level. Then when you have a particular level, you will check that, okay, I have a level. Now from that level, let's move to the next level. So you will, for that particular level, you will just take the size of that particular level at a particular queue, or take out all the nodes from that. And in the next level, take out all the nodes that are connected to that particular level inside the queue and push that inside the queue again, so that the new level is pushed inside the queue from that particular node or particular level. So you are taking out the nodes from the queue and pushing out the new level node. So you're going to the new level, the next level, taking out on the left hand side, on the right hand side of a particular node, pushing it back inside the queue so that you can go to the next level. And for the next level, you will like changing out the indexes as well. And whenever you got out of this while loop, you have the maximum width or among all the widths among the binary tree, and you just return out the max. That's it. That is the overall tree traversal. So it is O of n doing a level of traversal over this whole tree. That's it. That's the overall logic and the code part for this particular problem. If you still haven't doubts, you can mention out in the comment box of this problem. Thank you for watching the video till the end. I will see you in the next one. Till coding, and bye.